Hi everyone, my name is Enzi and I wanted to give a very quick tutorial on how to use formulas and the dragging feature in Excel. So this is a spreadsheet with some numbers that will be similar to the ones you'll be using in Lab 5. Here we have some initial area and initial length, and then 3 columns corresponding to elongation, engineering strain, and true strain. And so first, if we look at the elongation column, it only has 2 numbers in it right now, which is 0 and 0.1. And so we might want to continue filling this column, incrementing by 0.1 each time. We could type all the numbers, or what we can do is highlight the first 2, hover over this square in the bottom right corner, and then drag it down. And what this will do is it signals to Excel, please autocomplete the rest of the column using the pattern that you currently see in the existing cells. So from 0 to 0.1, Excel is going to assume this is addition by 0.1, so it'll autocomplete the column such that each cell is adding 0.1 to the one above it. And so there you go. This is an example of the dragging feature. Column D is something that actually comes with your data, so you get that for free. But column E, the engineering strain, is something you will have to compute in this lab. And so as you might recall, engineering strain is elongation divided by initial length, which is this value in column D divided by 5 in the cell B2. And so to tell Excel to do a calculation, we start each cell with an equal sign. And once you type an equal sign, you can actually just do the calculations, such as, 2 divided by 3, 0.67. But of course, that's not what we want. What we really want is to say this cell, so when we click it, you see it auto-populates D2 divided by B2. And so when we type enter, we say, 0, and it's 0. And so now if we hover over the same square and drag it, this again signals to Excel, okay, now just repeat this pattern. So in the third row, do D3 divided by B2, that value 5, do D4 divided by 5, D5 divided by 5, etc. Okay. When we do this sort of naively, we see that there's a bunch of division by zeros. What's going on? If we go to the cell and we click in it, we see, what's actually happening is that it not only followed the pattern for D, but it also did it for B. So whereas we had D2 divided by B2, there's now D3 divided by B3. And similarly, down here, we can also see the formula up here, we have D4 divided by B4 now. And so that's, as you might realize, not quite what we want. We want the numerator to change, but we don't want the denominator to change. We want to essentially lock the denominator to always be B2. The way to do this is if you go back to the original function, we can put dollar signs in front of the cell. So putting a dollar sign in front of the B and a dollar sign in front of the 2 will tell Excel, now when we drag this formula down, change the D to be D3, D4, D5, but keep the denominator fixed on the B column and the second row. So we'll do that, hover over the square, drag, and we see that the division carries through properly. It's D3 divided by B2, and then so on for D4 and D5. Okay, for true strain, it's pretty much the same. I'll just demonstrate with this cell. We type an equal sign, and now we need to actually run a function, the natural log, and in Excel there's a bunch of sort of keywords that already tell it already recognizes keywords as certain functions. So natural log is ln, open parentheses, the formula is 1 plus the engineering strain. So we don't want that. Instead, what we want is the engineering strain, which is E3, close parentheses, enter, and then it knows to sort of do this computation. We can drag to get some more numbers. The value will actually be pretty close due to just rounding right now. And you can see it starts to differ. And so yeah, this is an example of how formulas and dragging works in Excel. You're welcome to do the same in this or Google Sheets for this lab. If you're maybe a little more programming savvy, you can use MATLAB, Python, R. That might make some of the calculations easier if you're doing numerical integration, but otherwise this is totally sufficient. Hope this helped.